Hello, welcome to the Shack of M1 GEO. Please excuse the mess. Over the last, I guess, 12 or so hours I've been reverse engineering the PCIe connector on the Raspberry Pi 5. Let's see what this pin here is. It's a 16 pin FPC connector on the Raspberry Pi, and you would have seen this. I've got a picture of it perhaps here. So I've been reverse engineering what these look like, and I'll kind of talk a bit more about that, but you'll have seen this connector on the edge of the Raspberry Pi 5. So this is a reverse engineering, is the first thing to say. So it's not official at all. I've been playing around with it, but I have got it to work. Only at Gen 1, but you will see why that is in a minute, just because of the haphazard way of which I've done it, rather than anything more scientific. So yeah, let's go through it. So if you enable the PCIe support for the connector in the kernel options, so you have to edit boot config and enable the PCIe in there, and that's listed on the Pi website. So if you add this device tree overlay, that enables the second root port. Actually, the first root port is by 1. It comes out to be, and that then enables the port. And if you do that, when you restart the Pi, when you reboot the Pi, you get this this signal here driven pin 3. I've called it, but really it's probably, I don't know how they're numbering this connector, but it's the one. So I should probably explain, these 1 and 2 are part of the connector frame. They're grounded, as is 19 and 20. So really you've got what would be 3 to 18, which is 1 to 16. I don't know how they're numbered exactly, but this is pin 3 here is on the Raspberry Pi is this one here. On the Pi, so on the board edge, near the GPIO, that pin there is driven high for about 420 milliseconds, and it's driven as well, so it will sink a reasonable amount of current. I tried it into a 220 ohm resistor, and it doesn't sag at all, so it's driven hard at 3v3. I don't know whether it's supposed to drive a transistor and reset or what. I'm not sure what it's supposed to do. These 4 here, so pins 3, 4, 5 and 6 on this pin out, which are really 1, 2, 3, 4 or whatever, they're sideband signals, so they're quite difficult to work out what they are. This one is obvious because it kind of pulses up and then comes back down again. That's very clear, and it happens every time it reboots. So I didn't know if that's a reset signal, and the inverse of that would make sense. If it was driving a FET or something, the inverse of that would be good for resetting any PCIe peripheral card. There's also this pin here, which is pulled up with a 47k resistor. Worked that out with Ohm's law. So just using a couple of different values of resistor, putting that to ground, measured the current through them, voltage across them, etc. Can work out the source impedance. That's 47k. So I guess that's some kind of presence detect, but I'm really not sure. These two here, these bottom two, they remain low. They don't do anything. I also put a 3K3 or 3K0, in fact, pull up to 3 volt on there, and they pull up easily with kind of 1 milliamp or so, and they don't they don't drop down at all or anything. So it isn't like they've been driven open drain. So I'm really not sure. I guess these two are inputs. My guess is that one way or the other there'll be clock request and the wake signal from a peripheral card to the Pi root port, root complex, but I can't tell which way around they are. And generally speaking, in my somewhat limited, I grant you, but some limited experience with PCIe in a professional space, this stuff just wants to work. If it's going to go, it's going to go. And that's the case with the Pi. So I have not connected any of these peripherals up. These are all just left as connected on mine. I'm literally just bonding the grounds together on my PCB here, on my little hacky, you'll see it in a minute, test jig. Just connected the grounds together, and then I've got a differential clock pair differential transmit pair, differential receive pair, and differential clock pair. Reverse engineering of these was pretty easy actually. I was expecting to have to do something quite complicated, but didn't end up being too complicated at all. The transmit pair are obvious. They've got capacitors next to the Broadcom chip. That's part of the PCIe standard. So the transmit side has caps on it. So that means it's data going out of the Pi into the card. So these are host to card H2C. So they're out of the Pi into the card. Then you've got the receive pair and the clock. Are the only two that don't have capacitors etc. around them on the board, at least on the Pi board at least. So I poked around them all with a scope. This differential clock pair, and you can see the two are routed differentially on the PCB. So this pair you can see just by looking at the PCB are the clock, and you can see that because there's a clock output 54 meg, I think. I don't know why it's 54 meg, maybe it's something else or some auxiliary function, I'm not sure, but it's 54 megahertz clock, which is not the PCIe clock frequency. PCIe clock reference clock is 100 megahertz. So it's PCIe clock pair. If you enable it with a software overlay during this reset time, you see this 100 megahertz clock. You don't see it any further if there's nothing connected. So it does this kind of reset sequence after a couple of seconds. If nothing talks to it, it goes back to 54 meg or some weird clock or some kind of noise or bursty nature. I didn't quite debug the bottom of that. It didn't matter for what I was doing. So yeah, those two are easy. There's a clock comes out of it, so that only leaves the other two as the receive pair. It's difficult to tell which way is the P and N, and I may have that wrong on here. I took an educated guess based on what the track layout looked like and how it kind of come out of the chip, and just having worked with Broadcom PCIe stuff before, switches, just professional experience having used their switches before. Just took a guess, 50-50. I figured if you were a nice engineer laying this out, you'd have all the P's on one side, all the N's on the other, or you'd do something sort of systematic. So I went for all of the P's on this edge, all of the N's on that edge, on the inside, and this on the outside of the board, and it worked first time. So there's two options: it doesn't matter, or this is the right way round. But yeah, as I said, I've only got it going at Gen 1, so maybe it matters for Gen 2, and that's why it doesn't work. I don't know. Your mileage may vary. So that's kind of all I've got here. Obviously the other thing is that the Pi, these just seems to be connected to the 5-volt rail on the Pi. I saw a note somewhere, I think it might have been in Jeff Geerling's video.
Before I wrap up PCIe, I should note the connector only delivers about 5 watts max over the 5-volt power line. So something like an NVMe hat might need a 12-volt barrel plug that powers it and the Pi. We'll see.
I'm not using that at all, and you'll see in a second what I've done. So this was the startings of a breakout board. There's also the PCIe connector here, and I'll put this schematic up on GitHub or on my website or something. So this is just a standard connector. I also have access to the PCIe Express, and there's some relevant notes pulled out of the spec here, as well as some other stuff here, like what's optional, what isn't optional. I was trying to use this to work out what pins may have been present on this as well. So there's also 2 of these pins down here, are 5-volt as well. So they go in there. It's not the nicest layout, this, but you can kind of see where it's going. So yeah, that's basically what that is. And just connecting these 6 pins and ground is enough to get the PCIe working, at least at Gen 1. And so you can see that what I've got here is a by 1 slot footprint. 12 volt is coming from a lab power supply here, and here. So this is just bonded together. All the grounds are connected together. I am using. So this was for a board I'm trying to design. I'm using at the moment a riser card from an old server as a breakout board, just to test this and work out whether I was on the right track or not. And so the pull-up resistors and stuff are not present at all. Everything is just floating. So all I've got connected is the transmit pair, the clock pair and the receive pair. So transmit and receive for the lanes and the clock. And I've also connected 3v3 and 3v3A. This is the aux voltage. I've connected those two power supplies up and the 12 volt up to power from a lab power supply, and I've pulled up the PCIe Express reset. So that's, the card is not reset, and the card needs to be pulled out of reset for it to do anything. So it won't work if the card's reset. You have to have that pulled up, and I just tacked a quick resistor on the side to just pull this line here up from 3v3 aux on my bodge. All of the rest of this is unused. Yes, so the present detect and stuff not connected on my board. So let me re-tilt the screen and I'll show you what's going on with the bodge that I've made, and those with a sensitive disposition should look away now. Okay, you were warned. Let's grab these tweezers here so I can point you through. So Raspberry Pi CM4, I removed the flat flex FPC connector here. Reason I removed this was because I wanted to have a look at the traces underneath here. Originally I was going to unsolder it, have a quick look, take a few pictures, solder it back on again. Just clumsiness. Anybody that knows me will know my nature. Clumsiness, so I destroyed the connector in the removing, but I was really worried about saving the board. So yeah, this board has been absolutely abused now. It's been soldered hundreds of times and it is starting to show signs of wear, but there we go. It got there in the end. This is the little riser card. It costs about £2 on AliExpress. I had it kicking around. I didn't have any other way to connect to PCIe cards, and I didn't want to solder to a connector, so solder to a card. So this was the only thing with a connector on it that I had. I've just soldered to the gold fingers. This was basically scrap. I had no use for it at all. There's this thing down here is a monolithic power solutions switching module. It takes 12 volt in, which is on this red cable here, and blue cable, so the lab power supplies across these two. It takes 12 volt into the card and also drops it down to 3 volt into here. There's a pull-up resistor which you can possibly just see hiding under here, just through there. There's a pull-up resistor, that's the pull-up for the reset, and then this orange cable here is the reset line, and that allows me to just tap it onto the ground here to reset the card if I need to. Yeah, so you can pretty much see what's going on here. There's the orange is the clock pair, then the brown here, this and this, is the receive pair, and then the two purples are the transmit pair. And you can see clock and receive go to side A of the board, the transmit line goes to side B of the board. Power and stuff is all bonded on this module, so I haven't had to tag it to everywhere. The board is stitched together enough that the powers are dissipated all around. So I have a couple of cards. Easiest to show is a PCIe card. If I plug that in a second, then we'll boot it up and show you it working. The socket's live. I don't know if you can see. Let me zoom out a little bit. I have to excuse the junk in the workshop here. Let's move it up a little bit. Can't do because I need that. Yeah. So if you see, plug this in, and you can see that the socket's on here. The power's on here, and the board's connected. Let's flip back to the screen, and if I grab the putty session that I was using previously, which I appear to have lost now. Is there not one running? Nope, apparently not. Okay, let's reconnect. So this one's called Pi-5 local, but it's turned off at the moment, so just hold that there. So if the trusty Pi5 USB cable, I'm plugging that into the Pi just below the shot here. So this is now booting, hopefully. Yep. Give it a moment or two, wait for the LED to stop flickering. Okay, let's gamble that it's booted by now, and it has. So, let's log in as me. with my super secret password. And just to show that this is the machine I just turned on. It's a little bit sluggish, but yeah, 0 minutes. It's just coming up now. Okay, so if I make the window a little bit bigger so we can read what's going on, we can do this function here, which is look at the kernel logs and look for anything that mentions PCIe, and there's some interesting stuff in here. So weirdly, start at the bottom, you'll see here there's a note that says PCIe host bridge to bus 1 is up, and then you see link here. Now this is the by4 link, and this is the one that goes to the RP1 device, and that's up at 5 gigatransactions per second, which is a Gen 2 speed. And you see it says forced at Gen 2. So this is this chunk here, sort of all of this highlighted now. This chunk is the usual Pi5 PCIe shenanigans going on. The interesting stuff is this section up here, which is the other one, the one we've enabled and the one we're playing with and the one we've soldered. The most exciting part, I guess, if that's a term we could use, is link up. And you can see it's at 2.5 gigatransactions per second, which is Gen 1. I tried forcing it to Gen 3, I tried forcing it to Gen 2. Just the physical wiring is nowhere near good enough. And you could see that when you looked at it. That it's not controlled impedance, it's length matched with a pair of side cutters and some dodgy soldering. So it's absolutely not in accordance with the spec, but it does work at Gen 1. And you can see link up. So if I do ls PCI, you can see here that there is this 0,0 bridge, so the 0,0 root complex, which is our one. We've just set up here, so these two here, this is the 0th one, and that's got this network controller Broadcom wireless network adapter, which is the red sort of card that I plugged in earlier on, in the slot. And then you can see the second bridge here, same part, and that's connected to one. That's the Ethernet controller here. So that's the physical Ethernet controller inside the RP1 on the board. So there's the two devices. If I halt it, so it stopped. I physically remove the card, pulled the card out. You can see it here. And then I just tap the new power button again and let it boot. The fans are spinning up and it's booting. And I do restart session. It hasn't quite. Oh, there we go. Got a login prompt back. I do my super secret password again. If we go back up again, redoing this, you will see now link down on the first one because there's no card plugged in. That's because the card is here. So yeah, that's pretty much all there is to show. I suppose ls PCI only shows the two ports, the two peripherals, the one Broadcom controller and the physical Ethernet thingy on the cable Ethernet on the RP1 chip, and the Wi-Fi card that we saw earlier and the other Broadcom bridge are missing. Post thought, I've added the, I'll show you quickly, the USB and FireWire card in. So there's 3 USBs, I guess one of the USB goes to the FireWire or something, and it's booted. Let's just go for gold ls PCI. And what do we get? Oh yeah, it comes up. I wasn't expecting that because it's a bit of an older card. Yeah, so here we go. Again, these two are just the bottom. These two are just the standard cabled Ethernet controller on the Pi, and the root complex going to the 4 lanes that go to the RP1 chip. All of this stuff is the USB and Firewire card by the looks of it. So you've got the other root port, the root complex. Oh, that's interesting. So there's this card is actually a PCI card, I guess, that's got a bridge in it. So there's a Texas Instruments part here, this part, which is converting the PCIe Express to just old school PCI. So PCI Express to PCI bridge, and then there's obviously some there's obviously a USB controller on there, and a second USB controller, I guess. This is not my area of expertise. There's like 2 USB controllers and then some kind of Firewire part as well. There's 3-port Phi, yeah, so I'm not sure exactly how it works, but yeah, interesting. But it comes up as well. Anyway, at risk of this turning into a video that lasts forever with me plugging random crapping, let's head into there. But hopefully you found it interesting, and thanks very much for watching. Cheers.